Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code, DTC P2A00, refers to an issue with the air-fuel A sensor 1, indicating a circuit range or performance problem. This sensor plays a pivotal role in measuring the air-fuel mixture that enters the engine. Located in the exhaust system, typically before the catalytic converter, the air-fuel A sensor 1 ensures that the engine receives the correct mixture for optimal combustion and efficiency. If it fails or operates incorrectly, it can lead to poor engine performance, increased emissions, and even potential damage to exhaust components. Addressing this DTC involves checking the sensor's functionality and its connections, as well as evaluating the engine control module, ECM, for any faults. Understanding the defined causes and symptoms will guide the technician through effective troubleshooting. DTC P2A00 signifies a problem with AF sensor 1, which directly impacts vehicle performance. The AF sensor is designed to monitor the proportion of air and fuel in the mixture that enters the combustion chamber. This sensor is positioned in the exhaust system, typically upstream of the catalytic converter, allowing it to measure gases right after combustion. By accurately detecting the air-fuel ratio, it sends data to the ECM, which adjusts fuel delivery and ignition timing as necessary. If the sensor fails to provide accurate readings due to internal faults or connection issues, the engine may run inefficiently, affecting fuel economy and emissions. Thus, recognizing the location and function of AF sensor 1 is crucial for targeting the source of the problem. Several causes can lead to the DTC P2A00 being triggered. A primary cause is a faulty AFAC sensor 1, which can malfunction due to wear, contamination, or internal failure. Such a malfunction may prevent the sensor from providing accurate air-fuel mixture readings, thus impairing engine performance. Additionally, poor electrical connections at the sensor or the engine control module, ECM, can also result in intermittent signals being sent, leading to incorrect operational readings. The ECM, or Powertrain Control Module, PCM, orchestrates the vehicle's engine operation. Hence, any flaws within it can further cause the AFAC sensor's performance to be misinterpreted. Each of these components need careful inspection during troubleshooting to pinpoint the issue effectively. Drivers may notice several symptoms when DTC P2A00 is present. The most immediate warning is the check engine light activating on the dashboard, signaling that the vehicle's onboard diagnostics have detected an issue. Additionally, poor fuel economy may occur as the engine struggles to maintain the right air-fuel mixture, which disrupts optimal combustion. Drivers may also experience rough idling or stalling due to inefficient performance from the engine at low speeds. Such symptoms may range from minor inconveniences to significant operational problems, necessitating timely inspection and repair to prevent further complications in vehicle functionality. The first step in troubleshooting DTC P2A00 is to turn the ignition switch to the on-key position. This action allows the vehicle's onboard diagnostic system to become active and prepare for further evaluations. As this step is carried out, it's important to not only clear the DTC with the Honda Diagnostic System, HDS, but also record all freeze data and any onboard snapshots. Freeze data is critical, as it captures the vehicle's operating conditions at the time the DTC was set, which could help in identifying patterns or specific conditions contributing to the fault. Additionally, it's essential to review any general troubleshooting information provided in the service manual to understand the likely causes and recommended techniques for diagnosis. After turning the ignition on, 2. The next action is to clear the DTC using the Honda Diagnostic System, HDS, equipped in your diagnostic toolkit. Clearing the DTC resets the monitoring system, allowing a fresh evaluation of the AF sensor's status once the engine is started. It is crucial to prepare for engine startup by ensuring that there is no load on the engine during this process. This means ensuring that an automatic transmission vehicle is in park or neutral, while a manual transmission should be in neutral as well. This setup allows for accurate monitoring and prevents any erratic behavior during testing or driving conditions that might affect sensor readings. Starting the engine is the next vital step in troubleshooting DTC P2A00. Hold the engine speed at about 3,000 RPM without any load, being careful to observe that the automatic transmission is in park or neutral, and manual in neutral to ensure stable operation. This procedure should be maintained until the radiator fan activates, which generally indicates the engine coolant temperature has reached a predetermined threshold. Upon the fan's engagement, it is advised to let the engine idle. This process is essential as it allows the engine to reach operational temperature, helping the AF sensor to output readings that reflect actual driving conditions. Monitoring the temperature during this phase is important for later tests. Next, you will need to conduct a test drive under specific conditions to verify the performance of the A-factor sensor and the system as a whole. Begin by ensuring the engine coolant temperature, ECT, sensor 1 is above 158 degrees Fahrenheit, 70 degrees Celsius, as this temperature aids in obtaining accurate readings. The vehicle should also be driven with the automatic transmission in drive or in third gear for manual transmission, within a speed range of 25 to 55 miles per hour, 40 to 88 kilometers per hour, for approximately 5 minutes. Following this, drive the vehicle steadily between 55 to 75 miles per hour, 88 to 120 kilometers per hour, for 10 seconds before fully decelerating without pressing the throttle for the next 4 seconds. Monitoring these parameters allows for the gathering of relevant data regarding the A-factor sensor's operational status under load conditions. Following the controlled test drive, the next step involves monitoring the onboard diagnostics (OBD) status with the HDS diagnostic scanner in the DTC's menu. It's critical to ascertain whether the screen indicates a passed or failed status for DTC P2A00. If the screen shows failed, it indicates that the system has detected an ongoing issue with the AF sensor. If it reports passed, it suggests that the sensor functions correctly at that moment. In this case, one should check for poor connections or loose terminals at AF sensor 1 and the engine control module, ECM, to prevent future issues. This step emphasizes the necessity of a detailed follow-up based on real-time data from the vehicle's diagnostics. If the DTC P2A00 shows a failure in the prior step, the next logical procedure is to turn the ignition switch to the lock position, effectively shutting down the engine and all electrical systems. Once the ignition is off, the A/F sensor, sensor 1, needs to be replaced. It's vital to ensure that the replacement sensor is compatible with the Honda Civic model, as different models or years may have varying specifications. After replacing the sensor, turn the ignition back to the on X position and prepare to reset the engine control module, ECM, or the powertrain control module, PCM, using the HDS to ensure that the new A/F sensor is recognized and operational with the engine management system. Once the A filter sensor has been installed and the ignition is back to on, 2, the next step is to reset the ECM or PCM using the HDS. This reset allows the vehicle's onboard computer system to reconfigure itself and incorporate the new sensor data into its operational framework. After resetting, it's crucial to perform an idle learn procedure. This procedure helps the ECM adapt to the new A-filter sensor's readings and adjusts fuel trim accordingly for optimal combustion. Managing these successive steps ensures that the system operates efficiently, adjusted to the new sensor dynamics while boosting vehicle performance moving forward. Following the reset and idle learn process, it's important to conduct another test drive under the same specified conditions mentioned in Step 4. Ensure that the engine coolant temperature, ECT, remains above 158 degrees Fahrenheit, 70 degrees Celsius, indicative of optimal engine operating conditions. This phase must again involve driving the vehicle at speeds between 25 to 55 miles per hour for 5 minutes, and then steadily cruising at 55 to 75 miles per hour for 10 seconds, followed by a full deceleration for 4 seconds without applying the throttle. These conditions allow for thorough testing of the new AF sensor's performance in real-world conditions, ensuring that the engine operates as expected and providing accurate data to the ECM for fuel regulation. Next, monitoring the OBD status for any pending or confirmed DTCs with the HDS is essential after the test drive. This will indicate whether DTC P2A00 or any other issues still persist following the sensor replacement and troubleshooting steps taken. If the error code reappears as indicated in the diagnostic, it's essential to go back and check for poor connections or loose terminals of the AF sensor and the ECM/PCM, as these could indicate underlying problems that need to be remedied. If there are no additional codes present, you can move on to the final evaluation of the DTC status. After voicing concern regarding potential pending DTCs, monitoring the OBD status in the DTC's menu again is necessary. The primary goal here is to determine whether the newly installed A-filament sensor is functioning correctly. If the screen indicates passed, this suggests troubleshooting is complete, confirming that all relevant issues have been addressed and the vehicle is operating as expected. Conversely, if the status indicates failed, further investigation into electrical connections or possible internal faults of the A-filament sensor or the ECM/PCM should take precedence. Confirming a pass allows the vehicle to resume regular operations without continued monitoring or repair tasks. As part of final repair verification for DTC P2A00, it is crucial to thoroughly confirm that the new A-final sensor is functioning as intended. This involves rechecking all connections to both the sensor and the ECM/PCM to ensure that there are no loose wires or faulty connections that could lead to further issues. Additionally, conducting a final scan using the HDS to check that no new or ongoing DTCs are present helps ensure the vehicle is in optimal condition post-repair. As part of good practice, document these results to maintain a history of the vehicle's diagnostics, ensuring that any recurring issues can be traced effectively. Completion of this verification step helps reassure the technician that the repair is successful and the vehicle is ready for regular use. Preventive maintenance is key in avoiding future occurrences of DTC P2A00. Regularly checking the A-sensor ensures that it is functioning within specified parameters, as sensors can degrade over time or become contaminated. Alongside this, a visual inspection of wiring and connections can catch potential issues early on before they lead to failures. Implementing a routine engine service, such as oil changes, air filter replacements, and spark plug inspections, can also contribute to the overall health of the engine and its components. By taking proactive measures, vehicle owners can promote long-term reliability, enhance fuel efficiency, and reduce the likelihood of unresolved engine management issues. In conclusion, DTC P2A00 indicates a significant issue related to the AF sensor, Sensor 1, in the exhaust system of the Honda Civic 2006 to 2011 models. Understanding both the function and the location of this sensor is pivotal for any effective troubleshooting approach. The steps outlined provide a systematic methodology for diagnosing and resolving the issue, from initial data recording through to final repair verification. Regular preventive maintenance practices will greatly benefit the longevity and performance of vehicle components, including engine sensors. By keeping a disciplined approach to vehicle care, owners can ensure their Civic operates efficiently and minimize the chance of reoccurrence of DTC issues. Please like and subscribe to the channel. See you next time.